welcome back. In this video, we're going to look at one of the most important big ideas in elementary geometry. How are quadrilaterals related to one another? This is where students often start asking really interesting questions. For example, elementary students often debate whether rectangles are squares or squares are rectangles. These two statements sound similar, but they do not mean the same thing. Let's look at the statement, squares are rectangles. Is that true? Yes, it is. Why? Because a rectangle is defined as a quadrilateral with 4 right angles. A square has 4 right angles, so it meets the definition of a rectangle. A square has some extra properties too, like 4 congruent sides, but that does not stop it from being a rectangle. Now, let's look at the other statement. Rectangles are squares. Is this true? No, this statement is not always true. Why not? Because not every rectangle has 4 equal sides. A rectangle only needs 4 right angles. Some rectangles are long and narrow. They are still rectangles, but they are not squares. So here's the key idea. Every square is a rectangle, but not every rectangle is a square. This is a wonderful example of how mathematics depends on definitions. Students need to focus on the properties that define each shape. So which properties of squares and rectangles matter most here? Students should focus on these. A rectangle has 4 right angles. A square has 4 right angles and 4 congruent sides. Since every square has 4 right angles, every square fits the definition of a rectangle. But since not every rectangle has 4 congruent sides, not every rectangle is a square. This kind of reasoning is about class inclusion. One category can fit inside of another category. Now, let's look at some other relationships we can see in quadrilaterals. A square is a rhombus because a rhombus has 4 congruent sides, and a square does too. A square is a parallelogram because its opposite sides are parallel. Using our inclusive definition, a parallelogram is a trapezoid because a trapezoid has at least 1 pair of parallel sides, and a parallelogram has 2 pairs of parallel sides. You can also point out that some relationships are not always true. For example, a kite is not always a rhombus. A trapezoid is not always a parallelogram. Or a rectangle is not always a square. These are helpful examples because they push students to think carefully about which properties are required. As future teachers, one of the best things you can do is ask students, what properties does this shape have? Which definition does it satisfy? Does it have all the features it needs to belong to this category? These questions move students away from thinking based only on appearance. A shape does not stop being a rectangle just because it's turned sideways. A square does not stop being a rectangle just because it looks special or more specific. That kind of flexible thinking is one of the goals of geometry instruction. Excellent work. This is deep mathematical thinking, and it is exactly the kind of reasoning that helps future teachers build strong, accurate ideas about geometry. Keep going. You're developing the kind of understanding that helps students move from memorizing shape names to truly making sense of mathematics.